Hi, this video is about producing electricity from water. The first method of producing electricity from water is looking at hydroelectric power. At most hydroelectric power plants, a valley is flooded by building a large dam in the way of a river. Whilst the water is behind the dam, it has gravitational potential energy. The water is then let through the dam at a controlled rate. The kinetic energy of the water turns the turbines, which then generates electricity. A positive of hydroelectric power is that it can respond well to a change in demand for electricity because the amount of water that is released is controlled. If electricity demand is low, they can reduce the amount of water that is let through the dam. If then electricity demand rises, they can increase the amount of water that is let through the dam, which causes the turbines to turn around more, which then causes more electricity to be generated. Another positive is that there are minimal running costs for a hydroelectric power plant. And a final positive is that it is a good way to generate electricity in remote areas. However, there are some negatives of hydroelectric power plants. One negative is that they have a very high initial cost. The Three Gorges Dam in China cost around 180 billion yuan, which is around 18 billion pounds. Also, there is a great impact on the environment due to a significant amount of land behind the dam being flooded. This causes humans and animals to be displaced. Furthermore, if there is a drought, the hydroelectric power station may not be able to generate electricity. But as the dam tends to hold a significant amount of water in reserve, it is unlikely that the dam will completely dry up, and therefore the dam should be able to continue to generate electricity if there was a drought. We are now going to look at pumped storage. Pumped storage is a way of meeting electricity demand. It is not a way of generating new power. In pumped storage, there are two reservoirs, a high reservoir and a low reservoir. Surplus energy is used to pump water from the low reservoir to the high reservoir. When the water is in the high reservoir, it has gravitational potential energy. When there is a sudden increase in the demand for electricity, water is released from the high reservoir to the low reservoir. As it is released, it passes through a turbine which generates electricity. These sudden increases in energy demand could be because everyone is cooking dinner or people are coming back from work and putting the kettle on. Being able to respond to changes in energy demand is a massive positive for pumped storage. Pumped storage can supplement the steady delivery of energy from power stations, which is the base load. Surplus energy usually comes about at night. This is because the boilers in power stations are kept running all the time, despite electricity demand being very low. With pumped storage, we need to remember that it is not a way of generating new power. It is only a way of storing power. We're now going to have a look at wave-powered turbines. Wave-powered turbines turn kinetic energy into electrical energy. As the waves come to the shore, they provide an up and down motion, pushing air through the turbine. The turbine is attached to a generator, and as the turbine moves, it generates electricity. Positives of generating power this way are that this method is a renewable energy resource. Also, there is no pollution created when the wave-powered turbines are creating power. Another positive is that they can generate electricity all day. This is because waves occur all the time. However, there are some negatives, such as they look unsightly. Also, they cannot respond to an increase in energy demand. This is because the amount of energy that they produce is dependent on how large the waves are. Furthermore, the initial cost is fairly high, and the amount of energy that they generate is fairly trivial. Furthermore, generation levels fluctuate depending on the weather conditions. The final method of generating power that we'll look at is tidal power. Tidal power can be turned into electricity by using a tidal barrage, which is a dam that is built across a river estuary. An estuary is a part of a river where the tide meets the sea. The water level of this part of the river will rise and fall with the tide. There are turbines in the tidal barrage. When the tide comes in, it fills up the estuary and turns the turbines in the tidal barrage. The barrage traps the water on one side and lets the water through at a controlled speed, which turns the turbines and generates electricity. By trapping water, there is a difference in the water level on either side of the barrage. When there is a difference in the water level on either side of the barrage, the side where the water level is higher, the water has gravitational potential energy. Tidal power is a renewable energy resource as the energy is created from gravity, the sun, and the moon. Also, there is no pollution caused when using this way to generate electricity. Furthermore, we can predict the heights of the tide and at what time they will occur with a good degree of accuracy. However, the heights of the tides do vary throughout the year. Another positive is that the running costs are fairly low. However, the turbines will not work 4 times a day when the water level is the same on the seaside and the riverside. It is 4 times because the tide comes in twice a day and the level will be the same when the water comes in and when the water goes out. So 2 times 2 is 4. Another negative is that the initial cost is very high. Furthermore, boats can be prevented from going up and down the river because there is a barrage in the way now. The UK government is thinking about giving permission for a company to build a tidal lagoon in Swansea Bay. This tidal lagoon will cost about £1.3 billion. For more videos, content, quizzes and past papers, go on to www.elevise.co.uk.